Hello everyone, this is our fourth lecture of module 2. In my previous lecture, we have completed the topics Rolle's theorem, Lagrange theorem and Cauchy mean value theorem. And today's topic is Taylor's theorem. Taylor's theorem, this is also known as generalized mean value theorem. Okay, so let's start today's topic, generalized mean value theorem. Generalized mean value theorem, okay, or it is called Taylor's theorem. Okay, so first question is why it is called generalized mean value theorem. Why generalized? So let me tell you, in Rolle's theorem, Lagrange theorem and Cauchy mean value theorem, we have taken the function, we have taken the first derivative of the function. Yes or no? Because the condition was fx is continuous and f is differentiable. Okay, here we have discussed about the first derivative of the function f. But in Taylor's mean value theorem, the function must be some finite number of differentiable. Okay, the function must be some finite number of differentiable or infinite number of differentiable. Clear? So let's start today's topic, Taylor's theorem. But let me tell you, Taylor's theorem may be for infinite series, maybe finite series. Now if the Taylor series is finite series, then depending on the last term, and the last term is called remainder. Okay, last term is called remainder. So depending on the last term or depending on the remainder, Taylor's theorems are two types. First one is Taylor's theorem with Lagrange remainder. Okay, and second one is Taylor's theorem with Cauchy remainder. Clear? So Taylor's theorem with Lagrange remainder and Taylor's theorem with Cauchy remainder. So let's start the first one, that is Taylor's theorem with Lagrange remainder. So first one. So obviously here we have a function f and an interval, closed interval ab, and I already have told you that Taylor's theorem is for some finite number of differentiable functions. Okay, so first statement is the, okay, let me write the full statement. Let f be a function defined on closed interval ab such that number one is the n-1th derivative will be continuous. Okay, so the n-1th derivative is continuous on closed interval ab. n-1th derivative, that means f n-1 x, that will be continuous. Okay, we write the first derivative as f dash, second derivative f double dash, third derivative f triple dash. So n-1th derivative will be f n-1. Clear? So the n-1th derivative will be continuous in closed interval ab. Clear? Now second condition is nth derivative exists. Okay, nth derivative of fx exists. Okay, nth derivative means fnx. So fnx exists where? On open interval a comma b. Clear? So if these two conditions hold, then there exists at least a point C belongs to open interval AB such that now you have to remember this result. Okay, this will be a lengthy result and you have to remember it. F of B, this is equals to FA plus B minus A into F dash A plus B minus A whole square by 2 factorial F double dash A plus B minus A whole cube divided by 3 factorial into F triple dash A plus dot dot dot. Let's write the n minus 1th term. B minus A whole to the power n minus 1 by n minus 1 factorial F n minus 1 A, and the last term B minus A whole to the power n divided by n factorial F n C. Okay, now let me explain. This is the result of Taylor's theorem. Okay, and this last term B minus A whole to the power n by n factorial F n C, this last term, this is called the Lagrange remainder. Lagrange remainder. Clear? Okay. Now you can see that here B minus A. This B minus A is increased by one multiple. Okay. First this is B minus A. Then you can see this is B minus A whole square. This is B minus A whole cube. And the n minus 1th term is B minus A whole to the power n minus 1 and so on. Okay. Okay. When this is B minus A, this is first derivative at the point A. When B minus A whole square, this is second derivative at the point A. When B minus A whole cube, this is third derivative at the point A. And when B minus A whole to the power n minus 1, this is n minus 1th derivative at the point A. But the last term is, this is B minus A whole to the power n, but this is the nth differentiable function, nth derivative at the point C. This is not at the point A. You have to remember this. The last term will be the Lagrange remainder term. This is the nth derivative at the point C. Okay. And also you can see that when B minus A to the power 1, the denominator is 1 factorial. B minus A whole square, the denominator is 2 factorial. B minus A whole cube, the denominator is 3 factorial. Okay, so depending on the power of B minus A, you have to divide by the same number factorial. Okay, so B minus A whole to the power n minus 1, you have to divide by n minus 1 factorial. Okay, so very simple. So in this way you can remember this formula. Clear? And the last term, this last term is called Lagrange remainder. Clear? So next theorem is Taylor's MVT with Cauchy remainder. So all the statements, all the terms will be almost same. The difference will be on the last term, because I already have told you that depending on the last term or depending on the remainder, Taylor's theorem are two types. So obviously the difference will be on the last term. Clear? So let's write the last term. Let's write the Taylor's theorem with Cauchy remainder. Taylor's theorem with Cauchy remainder. Okay, so I am not writing the statement. First statement will be same. F n minus 1 is continuous on closed interval AB, and second statement will be Fn exists on open interval AB. then there exists at least one point C belongs to open interval AB such that. Now let's write the result. F of B, this is equals to F A same plus B minus A into F dash A plus B minus A whole square by 2 factorial F double dash A plus B minus A whole cube by 3 factorial F triple dash A plus dot dot dot. Now let's write the n minus 1th term. B minus A whole to the power n minus 1 divided by n minus 1 factorial F n minus 1 A. Okay, and the last term. Last term will be 1 by n minus 1 factorial. This is not 1 by n factorial. This is 1 by n minus 1 factorial. Okay, into B minus A. Okay, into B minus C whole to the power n minus 1 into F n at the point C. Clear? You have to remember this. There is no short trick. You have to remember this last term. This is not B minus A whole to the power n. This is only just B minus A. B minus A into B minus C whole to the power n minus 1. And the denominator will be n minus 1 factorial. And this is same F and C. Clear? And this last term, this is known as Cauchy remainder. This is known as Cauchy remainder. Clear? So now you can now you have two types of Taylor's MVT with Lagrange remainder and Cauchy remainder. The Lagrange remainder is B minus A whole to the power n by n factorial F and C. Okay, let me write here. Lagrange remainder is B minus A whole to the power n by n factorial into F n C. This is Lagrange remainder. Okay, and which one is Cauchy remainder? This will be 1 by n minus 1 factorial. Okay, not B minus A whole to the power n. This will be only B minus A into B minus C whole to the power n minus 1. Okay, into F n C. This is called Cauchy remainder. This is called Cauchy remainder. Clear? In Lagrange mean value theorem, we have learned the another form of Lagrange MVT. Similarly, here we will learn another form of Taylor's MVT for both the remainders, Lagrange remainder and Cauchy remainder. Okay, so here we have written the condition in another form that we have to put B equals to A plus H. Yes or no? We have to put B equals to A plus H. So in this expression, if I write B equals to A plus H, so what will be the expression? F of A plus H, this is equals to F of A plus. If B equals to A plus H, so what will be B minus A? H. So this will be H into F dash A plus H square by 2 factorial F double dash A plus H cube by 3 factorial F triple dash A plus dot 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 n minus 1th term H to the power n minus 1 by n minus 1 factorial F n minus 1 A. Okay, and the last term H to the power n divided by n factorial into Fn. And in Lagrange mean value theorem, what is C? C is equals to A plus theta H, and I already have explained you that why C is equals to A plus theta H. So I am not explaining why C is equals to A plus theta H in this video. Okay, so Fn A plus theta H. Okay, this is the another form of Taylor's MVT with Lagrange remainder, and you must have to write that 0 less than theta less than 1. Okay, 0 less than theta less than 1, and obviously this last term this is known as Lagrange remainder. The last term is known as Lagrange remainder. Similarly, we can find out the second form of Taylor's MVT with Cauchy remainder. Process same. Put B equals to A plus H in this expression. Okay, let me remove this one. Okay, so another form. Put B equals to A plus H. So this will be f of A plus H. This is equals to f of A plus H into f dash A plus H square by 2 factorial f double dash A plus H cube by 3 factorial f triple dash A plus dot 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 h to the power n minus 1 by n minus 1 factorial f n minus 1 A, and the last term plus 1 by n minus 1 factorial into b minus a. B minus a means into h into b minus c whole to the power n minus 1. Acha, b is equals to a plus h and c is equals to, this will be minus, c is equals to a plus theta h, so this will be minus a minus theta h whole to the power n minus 1. Okay, into fn, c means a plus theta h. Clear? Now simplify this. So this will be fa plus h f dash a plus h square by 2 factorial f double dash a plus h cube by 3 factorial f triple dash a plus dot 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 plus h to the power n minus 1 by n minus 1 factorial f n minus 1 a plus last term 1 by n minus 1 factorial. Acha, this is h. Okay, and this a and a cancelled, this a cancelled, so h minus theta h whole to the power n minus 1, that means h to the power n minus 1 is common. Yes or no? H to the power n minus 1 is common, so we can take common h to the power n minus 1 into 1 minus theta whole to the power n minus 1 into fn a plus theta h. Okay, and here h into h to the power n minus 1, so obviously we can write it h to the power n, h to the power n. So what is the expression? Just I am writing the last term. So this will be h to the power n into 1 minus theta whole to the power n minus 1 divided by n minus 1 factorial into fn a plus theta h. Yes, so just write the last term. So this will be h to the power n into 1 minus theta whole to the power n minus 1 divided by n minus 1 factorial fn a plus theta h. Clear? Okay, and this last term is known as, you know, Cauchy remainder. Clear? So this was the topic, Taylor's MVT, and Taylor's MVT depending on the remainder term, two types: Taylor's MVT with Lagrange remainder, Taylor's MVT with Cauchy remainder, and we have discussed the second form for both two formulas. Clear? Now let's solve a problem. Suppose the question is this is a question from previous year. So question was, state Lagrange mean value theorem. State Lagrange mean value theorem. Write Taylor's formula for the function f of x equals to log of 1 plus x, okay, or minus 1 less than x less than infinity, okay, about x equals to 2 with Lagrange form of remainder after 3 terms. Solution. Okay, let me tell you. Okay, first of all, let's discuss the question. First part is state Lagrange mean value theorem. Okay, this is the first part. So already you know what is the statement of Lagrange mean value theorem. So I am not discussing this first part of the question. Let's come to the second part. Second part is write Taylor's formula. Okay, you have to write the Taylor's formula for the function, this function f of x equals to log of 1 plus x. Okay, and this function is defined on in this boundary. Okay, so we have to write the Taylor's formula for the function f of x, but about x equals to 2. Okay, you have to write the statement about x equals to 2 with Lagrange form of remainder. Okay, so first one is you have to write the Taylor's formula about the point x equals to 2, and which one? Lagrange form of remainder, and after 3 terms, and the remainder will be after 3 terms. Okay, now here let me explain you that when you are writing Lagrange, when you are writing Taylor's MVT, you must have to write the remainder term. Okay, if you are writing Taylor's MVT of finite terms, you must have to write the remainder term. You cannot neglect the remainder terms. Clear? So if it is given that remainder after 3 terms, that means here the value of n is 3. Okay, here the value of n is 3, so you have to put n equals to 3. Clear? And about x equals to 2, about x equals to 2, that means you have to put the value a is equals to 2. Clear? You have to put the value a is equals to 2. So let's start the problem. Solution. So first of all, here f of x equals to log of 1 plus x. Okay, so obviously here we have to use the Lagrange form of remainder. So by Taylor's MVT with Lagrange form of remainder. Lagrange form of remainder, what is the formula? F of a plus h, this is equals to f of a plus h f dash a plus h square by 2 factorial f double dash a plus h cube by 3 factorial f triple dash a plus dot 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 h to the power n minus 1 by n minus 1 factorial f n minus 1 a, and the last term h to the power n by n factorial fn c. This is the fn a plus theta h, a plus theta h. Okay, now according to the question, you have to put here, given that you have to write the expression about x equals to 2. About x equals to 2, that means you need not to put x equals to 2. Here the expression is you have to put a is equals to 2. Okay, so put a is equals to 2. Okay, also put h is equals to x minus 2. Okay, if it is given that about x equals to any variable, let's say any value, let's say k, that means you have to put a is equals to k and h is equals to x minus k. Clear? This is the method. You have to put a is equals to k and h is equals to x minus k. So let's start. Acha, one more thing. Here already given that you have to write the remainder after 3 terms. That means here n equals to 3. Okay, the maximum value of n is 3. So you have to start from n equals to 1, 2, 3. Clear? So start. First, a is equals to 2 and h is equals to x minus 2. So this will be f of a means 2 plus x minus 2. This is equals to f of a, that means f of 2, plus h, that means x minus 2 into f dash 2, plus h square, that means x minus 2 whole square divided by 2 factorial into f double dash 2. Okay, here you can see the value of n is 2. The question was you can write up to 3 terms. So the next term will be remainder term, because I already have told you, you cannot neglect the remainder term. The last term must be the remainder term. Okay, so for n equals to 3, you have to write the remainder term. And what is remainder? This one. This one. So this will be x minus 2 whole to the power 3 divided by 3 factorial into f3 a plus theta h, and a plus theta h means a means 2. So 2 plus theta into h means x minus 2. Okay, this is the expression. That means we are getting f of x equals to f of 2 plus x minus 2 into f dash 2 plus x minus 2 whole square divided by 2 factorial means 2 divided by 2 into f double dash 2 plus x minus 2 whole cube divided by 3 factorial means 6 into f 3 2 plus theta x minus 2. That means you are getting, okay, let's write this 2 plus theta x minus 2 theta. Okay, now problem is we don't know the value of f dash 2, f double dash 2 and f triple dash this expression. So obviously we have to find out the values of this unknown expressions. Okay, so let's say this is equation number 1. Now find out the value of f of 2, f dash 2 and so on. Clear? Now here f of x equals to log of 1 plus x. Yes or no? Log of 1 plus x. So what will be f of 2? F of 2 will be log of 3, na? Log of 3. Now what is f dash x? What is f dash x? F dash x means 1 by 1 plus x. So what will be f dash 2? So this is equals to 1 by 3. Okay, now what is f double dash x? This is equals to minus 1 by 1 plus x whole square. Okay, so what will be f double dash 2? So x equals to 2, that means 2 plus 1 3. So this will be 1 by minus 1 by 9. Okay, and the last one is f triple dash. What is f triple dash x? So this will be 1 plus x whole to the power minus 2 n into x to the power n minus 1. So this will be minus minus plus. So this will be 2 by 1 plus x whole cube. Clear? And we have to find out the value f triple dash. What is the value? 2 plus theta x minus 2 theta. Yes or no? 2 plus theta x minus 2 theta. So this is equals, just put x equals to this expression. So 2 divided by 1 plus 2 plus theta x minus 2 theta whole to the power 3. So you are getting 2 by 2 plus 1 3 plus 3 plus theta is common, theta into x minus 2 whole to the power 3. Okay, now just put the values of f2, f dash 2, f double dash 2 and this one in the equation number 1. So putting putting in 1. So what you are getting, fx is equals to, first f2 means log of 3, so fx is equals to log 3 plus x minus 2 divided by 3 minus x minus 2 whole square divided by, this one 9 and there was 2, so 18, x minus 2 whole square divided by 18 plus x minus 2 whole cube divided by, niche 6, this is 6 and this is 2. Just a minute. This is 2, so this will be 6 divided by 2, so that means 3 into 1 by, so this will be 3 plus theta into x minus 2 whole cube. Okay, and this is the final answer. This is the expression of f of x equals to log 1 plus x using Taylor's MVT, Lagrange remainder, about x equals to 2 up to 3 terms. Clear? This is the final answer. You will get many problems, this type of problems, for f of x equals to e to the power x, for f of x equals to sin x, and so on. Try all those problems. If you have any doubt, ask me. Okay, thank you so much.